In this video, I'll talk about the limits of a function. So before we start with the limits, so let's just do a little bit of recap what we already know about the function, the value of the function at a specific point. For example, in your pre-calculus, you learned that if you have a function which is defined by y is equal to fx and your function is 3x. And if you want to evaluate this function evaluate the value of function at x equals to 2. So what we do is we simply plug in the value x as 2, replace that in the function. So the value of the function at 2 would be 6. So now we're going to extend our thinking a little bit, and we're going to say that, so let's extend our thinking, and we're going to say that what happens to x, what happens to fx when x approaches 2. So we can say that when x approaches to 2, fx is approaching to 6. So we use this arrow for our notation approaches, and we read this as when x approaches to 2, fx approaches to 6. Now let's take a look at the graph given here. So if we look at the graph of this function fx, we can see that this function is not defined at, so let's say this is 1, and let's say this is, the y value is 2. So I don't know what the values are, but I'm just assuming, let's say x, when x is 1, so the function is not defined. So we see this hollow circle here. So it means, so this is a symbol for the function not existing at particular value of x. So in this case, at x equals to 1. So the value of function does not exist. The function is not defined at x equals to 1. And we can just assume that this function is defined by some algebraic function gx, and since it is not defined at x, so it means the denominator should have something like x minus 1. Because if you put 1 in here, so you will see that the denominator is 0. Provided the gx is non-zero, so we can define this function as gx over x minus 1. And then the question that we ask ourselves is, what happens to fx? What happens to fx? So now we are talking about this fx. So what happens to fx as x approaches to 1? So if you want to think about this, so take a look at the graph carefully and think about what happens to the y value when x is approaching to 1. Okay, so let's take a look. So when x is approaching to 1, so you can think of x is approaching to 1 from the left. So when x is approaching to 1, so y is approaching to 2. Similarly, when x is approaching to 1, so it can approach to 1 from the other side. So let's say we have a little bit more value than 1.001, and the y value is still approaching to 2. So small change in x, small change in y. So from here we can see that no matter how I approach x equals to 1, so what happens to my value, y value? So fx approaches to always, so it's getting really close to 2. And we say that, thus, we say that in mathematical form, limit as x approaching to 1, so the value of the function is equals to 2. So notice that even though the function does not define at x equal to 1, or even though f of 1 does not exist, we still have the limit value of the function. So in general, if you talk about the definition of a limit, so limit of a function fx is that value which the function approaches as x approaches the given value. So as x approaches to a, fx approaches to l. And when we talk about the limit, there are few things that we should notice. So L here is a real number. So when function approaches a real number, so this should be a real number that is defined. So L should be a real number. So if we have a finite real number, then we say that the limit exists. And L is the value of the limit of the function. So in order to find the limit of the function, we must look at both sides of x. So we must look at the negative side of the function. So we must look at the negative side of the function and see what is the value. And we must look at the positive side of the function near x and see what is the value of function. So you should look at both sides. So look at negative side of function, and we should look at positive side of the function. And when we look at both sides and we see that the both sides have the same value L in the neighborhood of x, so we say that the limit exists and the value is equal to that same value L. So if you look at only limit as x approaches to a from the negative side, and then we call this one-sided limit. Similarly, if we look at limit of x as approaches to a approaches from the positive side, so this we call also one-sided limit. So both the one-sided limit, the left and right limits, should be equal for a limit to exist. So these must be, and this must be same for limit to exist. For the limit to exist. All right, so let's just take a look at our previous graph. And now we're just going to take a look in detail. So just a recap, so what we're going to do is, so if you're trying to find the limit as x approaches to 1, what is the limit of the function? So in this case, so we can see that as x approaches to 1, so as x approaches to 1 from the positive side, so if this is your 1, and this is your 2. So as x approaching to 1 from the positive side, it means a little bit more value than 1, so 1.0001. So you can go as close as you want as close as you want to 1. So as x approaches to 1 from positive side or the right side, so we can see that the value of function y approaches to 2. So fx approaches to 2. Similarly, we can see that as x approaches to 1 from the negative side or from the left side, so again the value of y approaches to 2. So it gets really close to 2 as x approaches to 1 from negative side. So fx again approaches to 2, and we write that limit x approaches to 1 plus. So this is the notation that we use from the positive side or the right side. So limit as x approaches to 1 from the right side is equal to 2, and limit as x approaches to 1 from the negative side of fx is equal to 2. And since we know that we have 2, which is a real number, finite real number, so these two together imply that our limit x approaches to 1, fx is equal to 2. So if both the left hand side and the right hand side, or both the positive side and negative side, limiting values are equal, then we say that the limit exists and it's equal to that number. But on the other hand, if our limiting values are not equal from the both sides, then we say that limit does not exist. So you can just make a note that if limit x approaches to a plus fx is not equals to limit x approaches to a minus fx, so in that case we say that then limit x approaches to a fx does not exist. So TNE stands for does not exist. So this is a short form for not existing. So we can remember this note. And now, so we see that there are, of course, different methods of finding the limits. So we're going to discuss the 3 methods of finding the limits. And those 3 methods are called graphical method, table method, and algebraic method. So graphical method is good for visualization, but it's not practical. So this is useful for visualization, but not practical. So similarly, we have the table method, which is based on making a table, taking different values of x and find the corresponding values of y. So it's based on computation, and you have to do lots of calculations, but this is a time consuming method, but it always works. So time consuming, but always works. So the third method that we have is called the algebraic method. So algebraic method is it's like a shortcut method. So it involves the manipulation and some simplification of the computations. So it includes manipulation, simplification for the computation purposes. We're going to discuss these methods one by one in our next video. So in the next video, I'm going to discuss our graphical method. So please do watch that.